3, learning target 1D. I can graph a function and its inverse. So we're going to do 4 examples, and these 4 examples are the examples that we did in 1C. So as you can see, we've got f of x, f inverse of x for example 1. Example 2, 3, 4, they're all the exact same examples as what we did in Unit 3, Learning Target 1C. This is what you'll do for your packet problems too. You found the inverse for 1 through 8, and after you watch this video, you'll graph the two things. So looking at example 1, we've got 2x minus 4. If we took those numbers away, we would just have y equals x, which is linear. That's our parent function. So we know a line has like a starting point, a y-intercept, and a slope. So in example 1, our y-intercept is -4. Our slope is 2. So that means we're going to go up 2, right 1. So you come over to your graph. You start at -4 because that's your y-intercept. You're going to go up 2 over 1, up 2 over 1, up 2 over 1. Do it a few times. You could also go down 2, left 1. And then you make a nice straight linear line. F inverse, we've got x plus 4 over 2. That should be over 2. Well, this one's not quite so obvious because it doesn't look the exact same. A lot of people think, oh, there's a fraction, so it's rational. We'll look at rational in a little bit, but rational is only when you have x on the bottom. So this thing, if we put a 1 in front of x, we could rewrite it as 1 over 2x plus 4 divided by 2 is 2. So looking at it like that, it's pretty clear that our y-intercept is 2 and our slope is 1/2. So we go to plus 2, that's our starting point. We go up 1, right 2, up 1, right 2, or we could go down 1, left 2, down 1, left 2, and we draw our line. Alright, let's look at example 2. We graphed example 1, we graphed our original, we graphed our inverse. Example 2, again, it's written kind of like the inverse in example 1. So we would split that 3 into each piece. So we would say 2 over 3x plus 5 over 3. In the inverse, we would say 3 over 2. We're splitting the x into both things. And minus 5 over 2. Alright, now our graph on this one's going to be a little bit weird because we're not looking at whole numbers. Just do your best. It's a sketch. It doesn't have to be perfect. But we know that this is our starting point, and this tells us to move up 2 and right 3. So 5 over 3, that's not quite 2. So I'm going to put a dot, not quite at 2. If we take this and we move up 2 and right 3, would be about right there. We could also move down 2 and left 3. And then draw your line. Alright, our next one, our starting point, or our y-intercept, is -2/5. Our slope is up 3, right 2. So -2/5, that's 2.5. So we're going to go down -2.5. Our slope, we want to go up 3, right 2. Again, it's a sketch. It doesn't have to be perfect. Up 3, right 2. We could also go down 3, left 2. And draw your line. Next example, example 3. So both example 1 and 2, our parent function was linear. With example 3, our parent function is rational, which is 1 over x, because x is on the bottom. It's not because it's a fraction, it's because x is on the bottom of that fraction. So let's just do a real quick reminder. Our normal graph looks like this. Where it's kind of centered around the origin. It's kind of like that's the middle piece. So looking at your h of x, your original, we've got 2 over x for both original and inverse. So that 2 is not going to change a whole lot. Since they both have 2, it doesn't really affect it. But this piece has a +1. So think about your transformations. Since it's with x, it's opposite of what you'd think, so it's going to be left 1. So if we took this center piece and we moved it left 1, our new center piece is going to be right here at -1. So we draw that graph as if that new dot was the origin. Our inverse, we've got 2 over x. Again, since they both have 2, it doesn't really change a whole lot. But we've got an extra -1 at the end. At the end is our up and down. And since it's negative, we're going to move down 1. So instead of being at the center, the origin, we're going to move down 1. So you draw your graph as if -1 right here is the center. So our new graph would look something like that. Last example. Again, we're rational because x is on the bottom. With our f of x, we're going to move right 1 because it's with the x and it's negative. We're also going to move down 1. So if we take that center and we move right 1 and down 1, that's your new center. So you draw those 2 pieces around that new center dot. Looks something like that. Our inverse, we've got a left 1 because it's with x and positive, and an up 1 because it's outside and negative. Again, they both have 3 on top, so it's not really going to change a whole lot. But we need to be at the center. We need to move left 1 and up 1, so that's our new center. We draw those 2 pieces just like they look normally, except we're shifted to the left and up. Alright, so we've got all 4 of these graphs and their inverses drawn. What I'd like for you to notice, all of these graphs are kind of symmetrical to some sense. If you look at that y equals x line, on each of these things, that y equals x line is just that diagonal line. If we look at that line, if we could physically pick up this top side these top two pieces that are above that line, if we could flip them over that line, then we're going to get these two pieces. Same idea with like example 3. We've got this piece and this piece. And if we flipped them over that line, it'd be this piece and this piece. Same thing up on this end of things. We've got these two pieces. If we could pick the graph up and fold it over that line, we'd get these two pieces. So when you're graphing an inverse, if you can fold it over that y equals x line and they would land on top of each other, then you know you've done it correctly. Inverse graphs reflect over y equals x. That's all you got.